In this video, we're going to talk about descriptive and inferential statistics. So first of all, I got some data here. These are college tuitions from 1993. That's actually the year I graduated from high school, believe it or not. And you can see these are the tuitions from all the different colleges in the United States. And you can see there's a lot of data here. So oftentimes in the actual classroom, I'll hand this data out and I'll ask the person, what do they learn from this data? And they take the data out and look at it and kind of just shrug, and they usually say something like, well, there's a lot of colleges, or there's a lot of data there. And that's exactly what I want them to say, that when the data is not organized at all, then it doesn't tell you very much. It's not at all clear how you can use all these numbers to draw conclusions and to make decisions based on the data. So the first thing that you need to be able to do in order to do statistics is to be able to organize the data so that you understand what the data is saying. And the techniques we use to organize data is known as descriptive statistics. So let me give you a definition here. So descriptive statistics would be the techniques of organizing and presenting data. To organize it and present the data, make sense out of it. And the ways that we do this, we make charts, tables, graphs. We might do things like calculate the mean, median, mode. We might calculate the standard deviation, which tells you how much variation there is in the data. We're going to learn about a lot of these things as we go on here. There's things called percentiles, and then I'll just say etc. And so the point here is these are all techniques that you use to organize the data or to present it in some way so someone can kind of wrap their mind around the data. Now, as it happens, this data, I actually got this from the internet. This is actual data, college tuitions from 1993, and it came in an Excel file. I downloaded the Excel file, and so what I did is I actually organized my data. I used Excel to do some descriptive statistics, and so this will give you some examples. So for example, I found the minimum and maximum tuitions, $480 all the way up to $25,750. Okay, the average tuition was about $7,800. Now the amazing thing is, even with a calculator, if I were to type all these in and calculate the average, which would involve adding all of these up and dividing by the number of values, it would have taken me a long time, maybe several hours, to calculate this average, and very likely I would probably have some mistakes in there. But the software, when it's on the computer, like I brought it up in Excel and I said calculate the mean, and it literally calculated this in less than a second, just like a calculator would calculate something. And so it's just amazing. The standard deviation, this tells you how spread out the data is. Okay, so it's centered there at 7,800, right? And then it's about 5,000 either way, meaning kind of on average the different values vary from the mean, or from the average here, about 5,000. Some less, some more. But the standard deviation gives you a measure of how spread out the data set is. Now the standard deviation is a very large calculation, and it takes a lot longer than the mean to calculate. It's a lot more involved. And it's interesting because when you use Excel to calculate this, it doesn't do it in a second. It takes it about 2 seconds. But you can tell the time difference. There's a little delay. For the mean, you just hit, calculate mean. Boom, there it is. For the standard deviation, it'll be like, boom, boom, there it is. So there's that little bit of delay, so you know that the computer is performing some calculations at an amazing speed. So it's really cool to see that. So here's another thing we can do to organize the data. This is a table. This is called a frequency distribution table. So I'm taking that range from $480 all the way up to $25,000, and I'm breaking it up into equal intervals. So like 0 to 2,499, 2,500 to 4,999. So I'm going up by 2,500 each time. And then what I'm doing is I'm finding how much data lies in each of those intervals. So there were like 316 schools that were in this first interval from 0 to 2,499. 169 schools that were between 2,500 and 4,999, and so on. Okay, so these intervals are called classes, and the frequency is how many observations in the data set lie in each class. And when you do this, when you distribute the data into the different classes like this, you construct a frequency distribution table. And that tells you how the data is distributed over the possible values. And then you can make a diagram like this. This is called a histogram. And you can see that you have those intervals along the bottom, 0 to 2,500 to 5,000, 7,500, and so on. And then the height of each bar tells you how much data is in each of those intervals. And you can see over here, this is like 20,000, above 20,000. There were only a handful of schools that were that expensive. So some maybe Ivy League school or whatever. They barely show up on the graph, but if you actually look real close, there's like a little bit of blue there. But you can barely see it because this thing is going up by 50s. And so 3, 1, 2, they don't show up very much there. But there is a little bit of data there. So this picture gives you a nice visual picture of how that data is distributed. So all of these techniques are examples of descriptive statistics. Okay? These are ways that you organize the data set, and it allows you to see how the data is organized. And they involve charts, graphs, tables, mean, median, mode, standard deviation, so different numbers that measure things about the data set. If you've done any statistics up to this point, you have probably done descriptive statistics. So the other type of statistics is inferential statistics. And this is kind of a deeper branch of statistics. And it's really the kind of the goal of this course is to introduce you to inferential statistics. And we do this, the first 3 chapters are all descriptive statistics. It's the sort of stuff that I just showed you. A lot of that will possibly be review for some of you. You've maybe made a histogram, or you've calculated the mean, median, mode. And so these are important because the descriptive statistics forms the foundation for the inferential statistics. But the inferential statistics takes this a step further. And in order for you to fully understand this, we need to talk about how data is collected. So I'm going to do that first, and then I'll give a definition of inferential statistics. Okay? So in statistics, there's two ways to collect data. The first way is that you can take a census. And a census is when you collect data from the entire population. So if I wanted to find like maybe the average height of an adult male in America, it would mean I actually collected the height of every single adult male in America. Okay? Now in statistics, a population here does not have to be people. It doesn't have to be like the number of people in America or the number of people in Waterloo. In statistics, a population is all of the observations that you're interested in a particular study, or if you're trying to make a particular decision. So let's say I want to know how long batteries last. Okay, then the population I would be interested in. Let's say if I work for a battery company, then what I would be interested in is how long each and every battery lasts. If I took a census, I would have to actually test every battery and see how long every battery lasts. Now you can see that there's a problem with that, because in order to test the battery, you have to put it in something and drain it, right? You have to kind of ruin the battery. So oftentimes a census isn't the best way to collect data. So let me give you another example to illustrate this. This is the one I give in class. Okay, so I hand this out to somebody and I have them read this. This is you work for a lumber company and you're a quality control inspector, and this is your task. You must test the strength of boards. To do this, you apply weight to a board until it breaks. The amount of weight the board is able to hold before it breaks is the strength of the board. So it's very important that you know how much weight the boards can hold, especially if they're going to use this to make homes or bridges or other structures. You got to know how much those boards can hold. So in this case, the population of interest would be all the boards produced by the lumber company. So if I were the quality control inspector, okay, then I wouldn't take a census, because in order to test a board, I have to apply weight to the board until the board breaks. And if I did a census, I would be breaking every board that the company makes, and that doesn't make any sense. So I wouldn't be doing a census. What I would do is I would take a sample. Okay? So a sample, let me write this down. A sample is a smaller group of observations randomly selected from the population used to represent the population. Okay, so, and this is important, randomly select and represent. So a sample, so if I worked for this lumber company, I might randomly select 50 boards, let's say, and I test those 50 boards. And I'm going to use that information to kind of represent the entire population, to give me an idea of the average strength of the boards in the entire population. And that's the idea behind a sample. So let me draw a picture of this. So in the example with the boards, the population is going to be all the boards produced by the company. Okay, So the population is all the boards produced by the company. And so I'm not going to test every board. I'm not going to do a census because that would break every single board. So what I'm going to do is I'm going to pull out a sample. Okay, now the sample is randomly selected. It's randomly selected from the population. I don't want to go into my warehouse and pick, 50 boards all on one shelf. Okay, because maybe those boards came from a certain tree or came from a certain geographical location or whatever. And that's not going to necessarily represent the entire population. It won't represent all of the boards. What I need is every single board in the warehouse to have the same chance of being in the sample as every other board. And that's the idea of randomness. There's no bias. Certain boards aren't more likely to be selected than other boards, but every board has the same chance of being selected. In doing that, that's the best way to ensure that your sample is going to be a good representation of the population. So this would be like 50 boards that are tested. 50 boards tested. So what is the inferential statistics then? Now we can define this. The inferential statistics. So we can define this as drawing a conclusion about the entire population based upon the information obtained from a sample. There we go. So the inferential statistics is you're going to draw a conclusion about the strength of all of the boards by studying the sample and then using that and making an inference. An inference. An inference is you don't have the full picture, but based upon the information you do have and your understanding of how things are related and stuff, you can kind of infer, and it's not just a guess, it's sort of an educated guess, or it is a prediction of what's happening in the population. Okay? And so this is why it's called inferential statistics, because you're using the information obtained from a sample in order to make an inference about the entire population. And actually, this is where descriptive statistics is used. So the descriptive statistics is used to organize information obtained, or organize the data obtained in a sample. So when you pull out a sample may have more than 50 values. Sample could have 5,000 values or even more. And so they have to organize the information in a sample, and that organizing is the descriptive statistics. And then the inferential statistics is where you go back and you draw a conclusion based, or a conclusion about the population based upon the sample. And this often uses probability, because the amount of error that you would expect, because the average weight of the 50 boards will not necessarily equal the average weight of all of the boards. And so there's going to be some sampling error. You should expect a certain amount of error. And that error is going to be governed by mathematical principles that come from the study of probability. So probability and statistics goes hand in hand. If you think of probability, it's like you're randomly selecting a marble from a jar. But in statistics, it's like you're randomly selecting an observation from a population. So you can see the connection there, right? So in inferential statistics, these things include things like estimation, margin of error, you're studying the error, hypothesis testing, in hypothesis testing, you're not actually estimating what the actual strength of the boards are, but maybe you're just testing to see if there's enough evidence to conclude that the average strength is greater than a certain amount, something like that. There's forecasting or making predictions. The idea here is like a good example would be when there's an election for the president, they're kind of forecasting who's going to win the election or whatever, and they do that. They pull out a sample, and based on that sample of voters, they draw a conclusion about who's going to win the election. And of course, it's not always correct. There's error, okay, but you can make fairly good predictions. And so, and you might also predict like what the the population is going to be, or what inflation is going to do. And in that case, you're using observations of the past as your sample to predict what's going to happen or infer what's going to happen in the future. And there's also studies like correlation and experimental studies. And we're going to look more at these at the end of chapter 1, but the idea here is you're going to be using samples in order to test the relationship between variables, like whether a certain medicine has an effect or not. And so that is also included under inferential statistics. So let me, I have an example here that's like the homework. Let's go ahead and look at these and then decide if they're descriptive or inferential. So if you want, what I encourage you to do is go ahead, pause the video and try to decide whether these are inferential or descriptive, okay? And then go ahead, start it up, and you can see how you did. Okay, so let's go ahead. Let's see how you did. So a teacher calculates the average test score for the students in his Introduction to Statistics class. That would be descriptive. He's finding the mean. The average is the mean, and you're using that to describe your data set. Okay. The second one, the ACT scores from a sample of 300 college freshmen are used to estimate the average ACT score for all college freshmen. And that is inferential. You're using the information in this sample to estimate what the score is going to be for all freshman students. In 2025, the world population is predicted to be 8 billion people. That's inferential, okay, making predictions. You're taking observations from the past to infer what's going to happen in the future. A researcher calculates the median income of all the families in a small town he's writing a report on. That's descriptive. Mean, median, mode, any of those numbers that you calculate to describe the data set in some way is examples of descriptive statistics. The police department of a large metropolitan area has kept a record of the annual homicide rates that have taken place in the area since 1970. And again, that's descriptive. This is just numbers that describe the data set. In this case, it's the annual homicide rate. And so they're not taking a sample and inferring anything. Now, if I said something like they take a sample, the police department takes a sample of, 10 different years and uses that to estimate what the rate has been, or something like that, or to predict what the rate's going to be, then it would be inferential. Okay, from a sample of 500 college graduates, it is determined a relationship exists between people's college degrees and their future income. That is, again, inferential. That's like a research study. That's a correlation study. So is there a relationship? They're using a sample of 500 college students to decide whether, in general, for all college students, whether a relationship exists between their degrees and their income. And then finally, to test the claims of a battery company, a quality control inspector tests a sample of 50 batteries and concludes the claims are being met. And this again is inferential. This would be maybe a hypothesis test. Maybe the company claims that the batteries last 20 hours and they test 50 batteries, and from that they conclude that there's enough evidence that the company is correct in saying that the batteries last 20 hours or more. Okay, that's inferential statistics. So this gives you an idea then about descriptive and inferential statistics.